Hello developers. In today's video we will get started with ESP-IDF in Visual Studio Code by a simple example. We will test the input and output functionality using a LED and a push button. We will create two tasks, one for controlling LED by turning it on and off every 500 milliseconds. And the other task will read a pin logic which will be connected to a button to see if it's pressed or not. So let's jump right in. First you will need ESP-IDF installed and configured in Visual Studio Code. I will leave some useful links in the description. Open a folder to organize and store your project files. Make sure that you have ESP-IDF extension in Visual Studio Code and configured with ESP-IDF that you installed. Click on ESP-IDF extension. And then open ESP-IDF terminal. Write this command in the terminal to create a basic ESP-IDF project structure in the folder you opened. We will open the IDF menu config to configure our project. Open the serial flasher configuration. Change the flash SPI speed to the supported speed on your board. Mine is 80. Change the flash size to your board flash size. Mine is 4 MB. Click S to save. And then click Escape to close the window. Put the code in main.c file. You will notice that the ESP libraries are not detected. Make sure that you have C++ extension. Click on Edit Include Path Setting. Include your ESP-IDF components and tools. Now the libraries are detected. The text DIO example will be displayed when we log messages to the monitor using tag macro. We are creating two macros for LED pin at GPIO number 2 and button pin at GPIO number 25. Creating two tasks using FreeRTOS API, one for LED and the other for button, each has 2 KB stack size and priority 5. In the LED task we set the direction as output by calling this function and giving it the pin number and the mode as output. These are the available pin modes. In the loop we set the level by calling this function that takes the pin number and the level. We are writing 1 for high and 0 for low every 500 milliseconds using v-task delay function, which will make the task enters the blocking state for this amount of time. In the button task we made the pin direction as input and using the internal pull-down resistor, so we don't need to connect external one with the button. Here are the available pull modes. In the loop we read the level of the pin using this function that takes the pin number and returns 1 if the pin level is high, which means that the button is pressed, and returns 0 if the pin level is low, which means that the button is not pressed. We are checking the pin level every 500 milliseconds. Click on this icon and select your ESP, click on the build icon to build your project. First build will take time. Connect your ESP. Select the flash method. Select the COM port your ESP connected to. Click on the flash icon to upload your code on the ESP. Click on the monitor icon to open the monitor terminal.